everyone, it's Anumodit Kumar. Welcome to Key Concept. In today's session, we are going to discuss about how to select different Psd settings and what are the different parameters that are related to the Psd setting. Rather than Psd, what are the different methods available for startup the VLDC motors. So the next startup method is Psd method. Psd or IPD both are same term. Initial position detection, position state detection. So both are same cases, different companies utilizing the different names. So more or less concept is same. Okay. So first is like how Psd work or IPD work. Okay. It utilizing inductive sensing methods. So inductive sensing method is used to determine the initial position of motor. Okay, when these features are actually these IPD or Psd enable. Okay, so what actually it means? So before starting the motor, first we need to know where exact rotor position are aligned. Once we know that position, then we energize our motor in such a the sequence of the phases in such a way that motor will start perfectly. Okay, so as we have discussed, like when we not required reverse rotation of the motor, we always go with this particular setting or a Psd or ISD setting. Okay, let's see how we do these activities. So as you see, if you have a motor and three-phase motors, and if you are your binding in this particular pattern, this is a binding pattern of the 16 pole and 18 slot. Okay, as you see, so let's assume some certain position where your already rotor is in a stationary condition. So what we need to do, usually we inject, you can see high voltage, you can see some certain voltage with the high frequency, some certain voltage with the high frequency to the motor terminal, all three terminals, and the sequence will what we are following. Usually we send you can say by sequentially applying the voltage across the two of the three phase of the motors, and that's the sequence is VW, WV, UV, VU, and WU and UW. So these are the sequentially be applying different high frequency voltages to the motor. Okay, and we have selected a clock that we are discussing, and in the same way with the drive that have the different you can say the time duration. Okay, and this is the Psd or ISD current thresholds. Okay, so current threshold setting basically refer to the time, how much time limits that you're going to provide. So once you provide this info, like sending these pulses, so what happened based on your magnitude, your different sequence of the, you can say, the phases, it reach to the threshold and then it settle. Okay, so we measure all the 6 sequences and measuring their settling time of the device. Okay, so as you assume, the U and V is having a very high settling time, okay, compared to others. And if you say the smallest time duration is V and U. So V and U what actually means? So this is the lowest, or you can say smallest inductance value inside the motor. So if your motor having what actually we have, okay, so V and U. So what actually happens? So V and U, let's assume this one A is considered to be U, V and W. So we have a V and U. Okay, so V and U, it means this is U and this is V. So which red one is binded in such a way. In the same way, B is also binded in such a way. So when you energize these two phases, the rotor resultant position of the rotor is closest to the N pole, right? So your current is saturated very fastly. It means that your motor inductance value is very small, okay? And the saturation position of the magnetic field that you are going to get in this particular condition. So if you energize the VU sequence, then you're going to get a very smooth startup, right? So what you need to do, you energize this sequence in an initial condition by sending like required whatever the like open loop like acceleration that you have provided to the system. So based on that, you select these sequence to energize this one. So every time you start the motor, they sending these, you can say they are sending the voltages, high frequency voltages to these certain sequence and sensing the lowest time duration. It means that the phase having lowest time duration, it means it has a, you can say, the closest distance with the N pole. And if the N pole is the closest duration, like distance is very less, it means that if you energize that particular phases, then your motor will spin in a forward direction, right? Hope you get the basic idea how it works. Okay. So usually when you sending these information, when you sending this like phases, once we get the information like which motor, which sequence is having the lesser time, or a lesser, you can say the phase inductance, the lesser inductance part that the motor which particular sequence. So how it's usually work, if you select the different phase angles, like you can say you have a three-phase vector. So let's assume I'm just drawing one phase vector diagram. Okay, sorry about my writing, I'm not able to write perfectly, so just assume U, V, W, some sequence. Okay, this one is 120 degree, this is also 120 degree. Okay, this is a three-phase vector diagram I'm just making. Okay, so if you taking this particular resultant path from this one, so equal variant is that like equal degree between these two angles. So if you taking this one angle here, W, it will 60 degree, this is also 60 degree, right? The same way you're taking this one, U, not W, U, and this is also 60 degree, and this is also, you can say 60 degree, and same way V comes here, this is also 60 degree, and this is also 60 degree, right? So let's see the same sequence that it has. So it's like I selected U and W. So U and W is U and W. It's 0 degree to 60 degree, right? So what actually it means, if you're sending high frequency voltages to the device and this particular phase is getting the time duration is shorter, it means like it has a, if it okay. So if you're this particular phase having a shorter time duration, it means like it has the lowest inductance part. It means that the rotor actually positioned between the 0 degree to 60 degree. Okay, so now you know the exact position of your rotor, right? if you're sending some high frequency to the motor, like like voltages, and you sense their position, and if you know this particular sequence in the motor is having like the lowest time duration or lowest inductance path, it means that motor is situated in 0 degree. And 0 degree of what, that's also important, low. So okay, no issue. So let's assume one motor, that's a 4-pole motor. So once you rotate your shaft of the motor, okay, you are going to get, you can say this one is like 1 cycle, okay, and you are going to get the total 2 cycles. Let's assume the motor having the 4-pole motor. So what actually it means, your each magnet, let's assume this is N, this is S, this is also N, and this is also S. Okay, so if you have 1, 2, 3, 4, it has a full 4-pole motor. It means it has a 1 electrical cycle. So electrical cycle, it means like 1 pair of magnet creates 1 electrical cycle, right? So this one is 90, this is 180, 270, 360, right, on the 0. The same way, if you're sending some high voltage, high frequency voltages to the motor, and you're sensing that this particular sequence, so you what assume your whatever the like position your rotor is, your whatever the stator that you position, that is between this particular angle, so it's below the, it's somewhere at 60, so it's in that particular position. So in that time you energize your sequence in such a way that you rotate your like motor in a perfect startup and in a forward direction. So you know the exact position of your end pole, and now you are able to energize your motor or start your motor in a forward direction in a very smooth way. Hope you're getting some basic idea. If you have some further query, let me know. I will come up with some more appropriate video regarding that, right? So this is all about the values that is related to the Psd working, how it actually works. Now next point, the high current, whenever you have a value, the Psd current threshold, if you go out to the Psd setting, you have a current threshold value. So current threshold basically values that refer to, you are selecting some values like some devices having like 0.8, you can say ampere to 2.4 ampere. Okay, so these up to this. So usually what you have to select based on your application, start from the lowest value or start from the highest value, and just start, usually we go for the lowest value and start keep increasing this value. For ceiling fan application I go with 1.6 ampere, and if you have 1.6 ampere, motor will start perfectly, right? So the higher current has better chance to accurately detect the initial position. Okay, but the same way, the higher current result vibration and noises. Okay, so the current should not be higher than the maximum current of the motor can handle. Let's assume your motor is capable to handle 2 ampere, and if you selecting this particular values 2.4 ampere, then it will fail to start the motor, and it will might also be possible to damage your motor also. Okay, so let's assume these two different graphs I have selected, screenshot of the graph. So this one is like you can say 1.2 ampere, and this one is 1.6 ampere. So as you can see, the amplitude of this particular graph, like height of this particular current, is 1.6 ampere. Okay, and this one is the value of this particular one is 1.2 ampere. Okay, so as we have discussed in our this particular point, so what actually it has, this is the same current, the current threshold value that we have. If you're selecting higher value, okay, and what it means, it will go for this one and they will come to this one, so the time duration also comes in a figure. So this four graphs get changed. Okay, if we take more time, sometime it also takes some more time. So if you're selecting higher value, it's a better chance to start your motor perfectly. In the same time, it will create some noise, and sometime it will also create some, you can say, the vibration and other things to the motor. So particularly always try to start with a medium, like you have to select the medium wave current, so it will operate your motor in a smooth way, and in a parallel it will not get start a failure and other things. Okay, so more or less idea to start motor in a smooth. So always, that's always depends on the observation that you are going to make. Okay, so till now we have seen how these parameters actually works, and what are the different facts that are related to the motor. So most of applications they sense these in the sense their sensing also depends on sometime two different methods. Like first is censored method, another is sensorless method. So censored method also utilizes very you can say the very useful method, like if you have a Hall effect sensor or a encoder, so they can sense the exact position of a rotor, and based on that they are going to energize your phases. But when we talk about the sensorless concept, you need to find exact position of your rotor, and based on that only you are going to inject the right current to the motor. So sometime if you are not able to select the right current, then it will create a vibration and the motor will not able to start perfectly. So for today's session, it's like we have discussed the Psd threshold and how it's work. In next session we are going to discuss about the clock angles and how it work, and what's the right angle to select for the different application. Then we go for different graphs, that all details that we have come up with the next lecture. So please continue and follow my lectures, and if you have any query, please do comment below so I can come up with the more efficient and more proper way for the different videos.